Yes, actually.
Hello.
Yes, sir. Shall we start, sir?
Yeah, sure. Should I share my screen?
Hello, everyone. Present here virtually. I am Nalini here, and I welcome you all for today's session, which is titled as Demystifying Blockchain Technology. And presenting this session, we have with us our today's expert, Dr. Siddhartha Roy. Dr. Siddhartha Roy is working as an assistant professor and head of computer science department, the Heritage College, Kolkata. He completed PhD in a computer engineering from Jadavpur University, India. He did MCA from IIST, previously Shibpur BE College, India. Obtained MBA in operational management and graduated in mathematics honors from Xavier's College, Kolkata, India. He had taken professional development training from TAFE, Adelaide, South Australia. His main research interest include machine learning, deep learning, blockchain application, and network security. He has several publications both in national and international level, peer-reviewed journals, and also the author of several textbooks in undergraduate levels. Dr. Roy has delivered lecture as an invited speaker resource person in a various national events. He is the editor and reviewer of many national and international journals. He had published one Indian patent and been rewarded for research excellence category like Global Innovation and Excellence Award, Green Thinkers International Adroit Educators Awards. He has more than 19 years of teaching experience. You can start now, sir.
Thank you, ma'am. Am I audible?
Yes, sir.
Okay. Thank you. Very good afternoon to all of you. So today I'm starting with the concept of blockchain technology. Now, in this concept of blockchain technology, what I shall discuss that is related to blockchain technology only, not related to the cryptocurrency or Bitcoin. Obviously, the Bitcoin or Ethereum that is closely related to the blockchain, but my approach is to develop or to talking the architecture of the blockchain technology, right? Now, what are the main outline today that I am going to discuss here? So first is why use blockchain technology? What are the basic cryptographic technique behind the blockchain technology? What is RSA and digital signature? What is blockchain architecture? And finally, I conclude my session with some typical application of blockchain technology. Now, if I want to define, before defining, let me give us the basic concept that what is blockchain. So blockchain, it is a system in which the information will be recorded in such a way that nobody can modify that information or hack or fraud the system. So that is the system. So basically this blockchain system is a digital ledger of transaction that is duplicated and distributed across the entire network of computer system on the blockchain. So basically, the blockchain is the backbone technology of digital currency. So the blockchain is the technology, and that will be implemented some digital cryptocurrency. So what is digital cryptocurrency? Basically, it is a encrypted data that will denote the unit of currency, such as Bitcoin, Ethereum, Litecoin. So these are the different types of cryptocurrency. Obviously, at the very beginning, I told that my approach is to discuss about the blockchain, not about the cryptocurrency. So that's why my approach will start from the different angle. So before give the proper definition of the blockchain, my first part is, let me start with the approach of the supply chain management. So let me review what is the successful supply chain management and how we can implement it properly. So for supply chain, we know that it is an umbrella activities where all business entities, they are involved in this part. They will involve and they need the proper coordination. What else? They require the real-time information from various business entities. Now, the question will come that how we can get the real-time information? Obviously, through web portal. Now, the question will that if we got the information in the web-based portal, is there any guarantee that the information is submitted is correct? If anyone denies the information later on, then what to do? Suppose we got the information and we find that some information is already there in the website given by some person, but later the person can deny that I am not giving that information, maybe wrongly posted by someone else on behalf of me. So what is the guarantee that what we are talking about, the information that is corrected? What is the guarantee that that will be not denied by someone? So for this, we need some decentralized solution where no one will trust each other and they should cooperate with each other. And here is the solution that is called the blockchain. So from this angle, we can find that what is blockchain. Now, what are the issues? Before discussing, now in this case, supply chain management, what's happened? There are different players are there, right? Business, entrepreneurs, any government or private bodies, or even individual. They can communicate in the business network. Everyone has his own fulfill of their goal, and they do not trust each other. So proper cooperation is required to obtain the desired goal. And that's why this is the trustless decentralization. And this trustless decentralization is called blockchain. That means in the whole business network, the first concept is it is decentralized. What does it mean? There will be no central control. There will be no central authority who will running this system. What is number two? Number two is that nobody will trust each other. It is totally trustless communication. And that is the trustless decentralization is nothing but the blockchain, right? Now, let me start with some typical scenario of the supply chain of computer industry. Now, in computer industry, what's happened? Suppose supplier, they simply give the information or simply supply the raw material. For what? For raw material for RAM or some processor or some CPU. Now, we know that we need different types of raw material like silicon, fiberglass, copper, transistor, capacitor to build or to develop each of the component for the CPU. So from the supplier, that material will be transmitted to the manufacturer who are going to transmit this part. Now, from the manufacturer, so there are different manufacturers. One will be the processor manufacturer, other will be motherboard manufacturer, other will be RAM manufacturer. What they will do, they will try to collect the raw material from the supplier, and that will be transferred to the assembly unit. What is the role of the assembly unit? They will now assemble those components. That means motherboard, processor, then RAM to form a particular single or PC, computer or laptop. Now, after that, that will be distributed to the warehouse. So this is the, and finally that will simply distributed to the customer. So that is the typical scenario of the supply chain of computer industry. Now, the fact is that here all information exists. Now, who will supply what unit of material, that is not transparent. So in this case, we assume that there will be a simple board where all information will be updated. In other words, we can say that all transaction will be updated, right? So what is the board? We assume that this is a single board where whatever the transaction will be performed, that will be updated from time to time. And what is assumption over here? The assumption is as follows. So board is shared with all the business entities. Just look at this figure. This board is shareable board. That means it will be shared by all the business entities, right? And the board has infinite space. That means whatever information will be entered over here, that cannot be deleted. So we assume that the board has infinite space. And everyone can view all the logs and verify any change in information that will be visible to everyone. And once the information entered, that cannot be deleted later. So that is the typical scenario for the supply chain of the computer industry. And we assume that there will be a single board that will be shared by each other. Now, whenever this is the scenario, that is the single board will be shared by each other. Now, there are different issues will raise. So what are the issues? First of all, we assume that there are the board which contain infinite storage capacity, but the problem is that who will maintain this board? Is there any service provider, cloud service provider exist? Then the next question will come that who will bear the cost? Okay, there must be some responsibility that who will bear the cost to maintain this board through some service provider. Now, suppose one of the enterprise maintain the private cloud. But what is the guarantee that it will be not fraud? Because that is private cloud. So what are the possible solution? Possible solution is that everyone maintain the same copy of the board individually and independently. There will be no central control on the board. There will be no central control of the board, and everybody will maintain the same copy of the board individually and independently. And no one is the sole owner of the data, but everyone has a copy of the data. There is no central database. So everything will be own or possess their own copy. Let us look at this scenario. See, now, previously, when we see the picture that a particular board is shared by all the business entities, but here we find each of them has their own copy. Mind it, it is infinitely large and it is used for the transaction. So this is called the blockchain. So what we assume, whenever any kind of transaction will take place between different kinds of business entities, then each of the entity, they have their own copy and they can see any kind of change or any kind of data is entered over here. As I told that previously, that the data, once it is entered, it cannot be deleted. So all the thing is transparent, and that is the concept of blockchain. So I start with the concept from the supply chain, and then now I am deriving the concept of blockchain. So what we are assuming, that everyone holds the exactly same copy of the data at the same instance of time, and immutable append only ever-growing chain of data, and data once added cannot be deleted or modified later. Number 3, as I mentioned, that there will be no central database. Everyone has a copy of the chain and process the data locally, and new information is added to the chain in the form of new block, right? Suppose in this block, some transaction, obviously, if we look at this transaction, every block has some capacity. I discuss later, but every block has some capacity. Why it is called blockchain? Because it will be chain of block. There will be another block will be appended to the newly created block will be appended to the previous one. In that way, we can append as many blocks as possible. There is no such restriction. Okay, this is here I am only showing you the one block, but actually it contains of the series of blocks. And so new information is added to the chain in the form of new block. And blockchain ensures that every party has the same view of the blockchain always. That means there will be no different view of the blockchain. And the information is transparent to everyone so that everyone can verify and validate. And a decentralized, immutable, append-only public ledger, right? So that is the definition of blockchain. So now come to the point of definition of the blockchain. So what is blockchain? An immutable, append-only, ever-growing chain of data. What does it mean? Immutable means it cannot be mutable. It cannot be changed. Append-only means whenever the new transactions are there, a block will be append with the existing data. An ever-growing chain means there is no such limit that how many block will be added up with a particular transaction block. And data once added cannot be deleted or modified later. So blockchain is a shared immutable ledger that facilitates the process of recording transaction and tracking assets in a business network. So virtually anything of value can be tracked and traded on a blockchain network, reducing the risks and cutting costs for all involved, right? So that is the definition of the blockchain. Now, to define the blockchain, there are some technology. Obviously, my topic is blockchain technology. So I discuss over here all the technological aspect and what technique or what technology that are used in the blockchain. So the very first thing that is used in the blockchain is called hash function. What is hash function? Hash function means it is used to connect the blocks in a chain in a tamper-proof way so that nobody can modify any kind of information. As I mentioned earlier, that once the information entered into the system, it cannot be removed or it cannot be deleted, right? So that's why this hash chain is used to connect the blocks in a chain in a tamper-proof way. That is first one. What is the second one? That is digital signature. So they will be digitally signed the data so that no one can deny later about their own activities. So what is the purpose of the digital signature? The purpose of the digital signature is to check the authenticity. That means once the transaction is completed, that will be verified for those business entities and they will agree on that particular transaction. So they cannot deny this particular fact of transaction, right? Now, to define this digital signature, we need two concepts. What are the concepts? One is called a cryptographic solution or cryptography or encryption decryption technique. Another is called the message digest. What is message digest? Message digest means it is just like a mapping function, we can say, where it will take some input and it will produce the fixed size output. What is the other part? That means if I apply the message digest on a particular message. Now, what is the size of the message? Message can be of any size. Message can be any size. But whenever we are getting the output will be always fixed length. So message can be any variable length, but the output will be always a fixed length. And this output, we call it as a message digest. And it is efficiently computable. That means there are particular mathematical functions are there to which we can use this particular hash function for this kind of message digest, right? So what are the characteristics of this hash function? This hash function is specially used for the message digest, and this message digest will be act as a signature, right? So this hash function, it is first of all, it will be deterministic. What does it mean? It will always give us the identical hash value for identical input data. What does it mean? If there are different input, we always get different output. It will not true that for different input, we'll get the same output. Number two, it will be collision free. That means if two messages are different, then their digest will also differ, just I mentioned. And hiding, it will never reveal the original message. It will always hide the original message. So that is the characteristics of the hash function. Okay. So if I say that X is the message and HX is the hash function, then from the HX, we can never find X. In other words, we can say this hash function is irreversible. Irreversible means we cannot apply the inverse value on this HX. And also it is difficult to find X and Y where X not equal to Y, but HX equal to HY. That is not possible. So if they are same, then their hash value will be same. If they differ, then their hash value will differ. So for a particular 256-bit hash function, the attacker needs to compute 2128 hash operation. And this is significantly time consuming, because if every hash computation function is take 1 microsecond, then it will need to take 1025 years. So huge time to compute this particular hash part. So now we can say that if HX equal to HY, that means two hashes are same, then the message also same. And we need to remember that just the hash value rather than the entire value, we call it as the message digest. So message digest, basically, it is the hash value of a particular message. And whenever X equal to Y, as I mentioned, that we can simply check if HX equal to HY, right? And why it is used for authentication? Suppose X is a message is transmitted over the network, okay, distributed public network. Now somebody change X. Then if somebody change X, then automatically the hash value will be changed. So receiver will change the obtained hash value with its computed hash value. If they differ, that means the particular sender is fraud. And if they same, that means the particular sender is the genuine one. In that way, this message digest is used for the hashing particular authentication part, right? So generally, the secure hash algorithm that is used over here, and there are different parties there. That means for the hashing function, one is MD5, message digest 5. Similarly, secure hash algorithm SHA that is used for that will use to generate 256 message digest. And part of this SHA2 is a set of cryptographic hash function that is designed by the United States National Security Agency. So this specially, this SHA256 is used for Bitcoin mining. That means to construct the Bitcoin blockchain. Okay, because other is used for authentication for simple document, but especially this SHA256 is used in the Bitcoin mining. Now, so as I mentioned previously, there are two parts. One is the digital signature. For digital signature, we need two parts. What is that? One is called a hash function, and another is the asymmetric cryptography or public key cryptography. These two concepts we require for the digital signature. Now, before discussing the public key cryptography, let me first discuss what is symmetric key cryptography. Symmetric key cryptography means there are two concepts are involved. One is encryption and another is decryption. What is encryption? Encryption means the message will be encoded, right? And when the message will be encoded, and that will be transmitted over the network so that nobody can decrypt this message. Only the receiver can decrypt this message. And that's why this is called the decryption. And how it will take place? It will take place through some key. So there will be some key that is used for this kind of symmetric cryptography. Actually, the concept of cryptography was started in Julius Caesar era in the battlefield, where they used to encode their message when they are communicating with each other. The same concept is used over here, right? So same key, that is public key, and private key, that is used for the symmetric key cryptography. And other is public key cryptography. Public key cryptography means there are two keys are involved over here. Now, the question will arise that why we are using the public key? What is the use of public key? What is the problem in symmetric key? Symmetric key means here in symmetric key, both party will use the same shareable key. So for the first time, when the sender encrypt the message, they will send the message along with the key, and that key will be communicated to the public network, which can be hacked by any intruder at any time. So the problem arises in the symmetric key cryptography is that key distribution problem. How the key will be distributed from sender to receiver? That is the main problem in the symmetric key cryptography. And that problem is resolved by the public key cryptography. Here, the same key will be not used by the two parties. Rather than different key will be used. A pair of keys will be used. What are the pair of keys? One key is called a public key, another key is called a private key. Okay. And in that case, the public key is used to encrypt the message. As I told you, what is called encrypted? Encrypted means it is used to convert a plain text into ciphertext. So ciphertext is called the particular encrypted message. So if I define it as M prime, so M prime, that means A is the encryption technique which will apply on the plain text with the help of the key, and that becomes M prime. What is decryption? Decryption, that is used to convert the ciphertext to the original plain text using the decryption as well as key. You find that here K is common. We find that here K is common is in this both case, right? So both case K is common, and in case of symmetric key distribution, this K will be the distribution of the K or sharing the info. This key is a problematic. So that's why in public key cryptography we use two keys. One is called the public key, another is the private key. Now, public key is used for encryption, whereas private key is used for decryption. One of the important algorithms in public key encryption is called RSA algorithm. So it is named by Rivest, Samir, and Adelaide, who invented this algorithm in the 1978. So this encryption key here will be public and decryption key will be private. Anyone can encrypt the data, but only the intended receiver can decrypt the data. Now the question comes that how the key distribution problem will be solved over here. Actually, there will be some key distribution center, trusted key distribution center, who will generate this kind of public and private key. And that key will be given to two parties. That is the main concept in the public key cryptography. Okay. And in this case, how it will take place, there are some mathematical calculation and algorithms is there. So for example, here we take P and Q is the very large number. Then we have to compute N, that is P into Q. After that, we have to compute the Euler function phi n equal to P minus 1 into Q minus 1, and choose E in such a way that 1 less than E less than phi a, and we take GCD of E comma phi n equal to 1, and E and phi n are co-prime to each other. And from there, we have to determine the D is equivalent to E minus 1 mod phi n, where D is the modular multiplicative inverse of E mod phi n, where D dot E, that is equivalent to 1 mod phi n. So this is actually the RSA algorithm. Now, this RSA algorithm, how the ciphertext will be completed? C is the ciphertext that will be completed on the plain text. So here plain text is given as M. So how ciphertext can be computed? Ciphertext can be computed by M to the power E mod n, right? Where n equal to p into q, where p and q are very large number. And how ciphertext can be, how plain text can be computed? Plain text can be computed c to the power d mod n. So in that way, the plain text can be computed. So from here, it is very difficult to figure out p and q. And from n and e, it is very difficult to figure out the d. And from n and e, it is, and c, it is difficult to figure out m such that c equal to me. So d and e, if anybody can compute d and e, then they can easily compute the message. But computing the d and e, it is very difficult part. It is actually unbreakable. So let us give some example for that. So for the time being, we just take p and q. Obviously, in reality, it should be very large number, but in fact, here we are taking very small number, p equal to 11 and q equal to 7. So what is n? We are taking the product of that, 11 into 7, 77. And we are taking phi n. What is phi n? Phi n means 11 minus 1, that is 10, and 7 minus 1, that is 6. So 10 into 6, that is 60. So now d equal to 13 and e equal to 37. How? Because ed equal to 4 to the power 8a and ed mod 60, that is equal to 1. From that, we can compute d and e. Let message m equal to 15. Then what will be c? C we can compute best m to the power e mod n. So c equal to, what is m? M is nothing but 15. 15 to the power 37 mod 77. So ciphertext will be, the value of the ciphertext will be 71, right? Similarly, from 71, how we can get the original message? How to decrypt it? So this C is actually the encryption, and how to decrypt it, because the receiver will decrypt the message to get back the original message from the ciphertext. So he will apply, because he has D, he will apply D, C to the power D, because he has C ciphertext. C stands for ciphertext. Ciphertext to the power D mod n. Every value is known to the receiver. From there, he will get back the original message. That means it will be 71 to the power 13 whole mod 77, that is equal to 15. And that is the actually the plain text, okay, using the RSA algorithm. So this digital or this blockchain, they use this kind of digital signature. And how digital signature? Digital signature composed of this public key cryptography as well as the message digest. Public key cryptography as well as the message digest, right? Now, so now I think digital signature is clear to you. That means digital signature is used to authenticate an electronic transmitted document. And basically it is the signing authority that can sign a document, but everyone can verify the signature. And signature is associated with the particular document, and it will prevent a non-repudiation. That means sender will not able to deny. Sender will not able to deny this particular original document, right? So that is the use for the digital signature. That is used for the digital signature, right? Now, next one is the, just a minute. Hello. I'm busy right now. Now, let me talking about the particular properties of the automated payment system. Now, why we use digital signature? Because whenever any information that will be shared and that have to be agreed by all the entities who are taking participation in the particular community. So they have to digitally sign it in this case of blockchain. Now, next part is the properties of the automated payment system. Here, inability to the third party to determine the pay time on the amount of pay made by the individual, and even the bank will not be able to track it. The main purpose of electronic cash or e-cash or Bitcoin or any kind of cryptocurrency is that nobody is going to control over this. Suppose whenever we are doing any kind of transaction, we know that our each and every transaction will be monitored and governed by some rules and regulation. That means there will be some RBI, RBI is there, government is there. The main purpose of this kind of cryptocurrency is that there will be no governing authority or there will be no central control over there, right? Now, in this case, the cryptocurrency was, in that concept, actually cryptocurrency was evolved. So there are two factors in our physical currency. What is the factors? One is any, suppose, old note that can be torn. Number two, there is a fear of theft for the existing physical notes. Third point is that there is some controlling authority or monitoring authority. In this case, cryptocurrency, actually, there will be that problem will be solved. So it is all digital money. There will be no physical money. How it will be not theft? Because it is secured. And how it will be secured? Because it will apply the cryptography. That's why this is called cryptocurrency. So currency which is in digital form, and not only digital form, but that will be in the encrypted form. And that's why this is cryptocurrency. So why this is so popular? First of all, I have some currency that is not physical currency, but digital currency, right? Number two, it is secured. How I can say it's secure? Because all currency is encrypted. That's why it is secure. Now, the concept was started in 2011 when Litecoin got introduced. After 2015, Ethereum network went alive. Then after that, sometime 2006, the blockchain got popular. Actually, the blockchain technology that was used at that time in 2016. And blockchain is the technology, not the cryptocurrency, mind it. Blockchain is the technology through which this kind of cryptocurrency would be implemented. And in 2009, Nakamoto, that mines the first block of Bitcoin network. And this is called the Genesis blocks. In 2013, Coinbase, another cryptocurrency that was evolved, and that's selling US $1 million worth of Bitcoin. Now, the question will come that how it will be generated, But before that, I am introducing that part later. First of all, it will be generated, Bitcoin will be generated by some miner. That's why this is called Bitcoin miner. But to generate that, who will generate the miner? That means who will generate the puzzle? The system will generate the puzzle, and that will be solved by some entities in the networking. I'm coming to that point later. But this puzzle is hard to solve, and it requires huge computing power. If I say that the DigiCon missed Bitcoin energy consumption index estimate that one Bitcoin transaction takes 1,544 kilowatt to compute, or to equivalence of approximately 53 days of power of the average US household. Think about it, the power consumption that is used in the generating a single Bitcoin. The source is from CNET. Okay. Now, for this one, we find that the Bitcoin is continuously increasing its value. In May 2010, it was less than 0.01 US dollar. In April 2014, it is $340 to $53. December 2017, it's become the $13,800. It will not see approximately dollar. And today, just I took this value today at 3 p.m. 29th March, the value become 47,694.62. Just think how the value is continuously, tremendously increasing in the Bitcoin. In fact, in today's market, the Bitcoin is much more popular than other cryptocurrency like Ethereum or other cryptocurrency part. So the point is that to generate the Bitcoin, we need some miner. Who is miner? Consider there is some open network where all nodes are connected and they don't trust each other. What is open network? Open network means a network where anybody can join anybody can leave. That is called open network. So there are two types of network, closed network and open network. Open network means anybody can join, anybody can leave in this particular network where some nodes are connected, where they don't trust each other. And among them, there will be a special nodes that is, they are called miners. What is the use? What actually miners will do? Miners will generate new block. How? They can solve some puzzle and add the solution as a proof of solving the challenge to be the leader. Now the question comes that I am telling the special node is called miner, but who will determine that a special node? Who is the special node? Who will determine that a particular node will be a special node? Right? So, and that is first question, that who will decide that who will be the leader? And second point is that how will decide, how it will, the leader will be decided? Leader will be decided because a complex puzzle will be given to the network. Who can solve the problem? They will be the leader. Who can solve the problem first? They can be the leader. So problem is solved. Who will be the leader? Who can solve the problem? Now the question comes that why they are going to solve this kind of complex puzzle? Because they can earn money. So in any kind of bitwork networks, there are two types of entities. Ones who are investing the money to get more money. Money means in terms of cryptocurrency, in terms of Bitcoin. And second point is miners who are getting the Bitcoin by solving the complex problem. So that is their motto. If they can solve the complex problem, then they can earn money, huge money. That's why they are called a mining a block, and that is called a reward, right? Now, so in this Bitcoin network, the encourage to the community to participate in the mining through incentives. What is the incentives there? That is the Bitcoin. So it will produce new Bitcoins in the system, and the Bitcoin network works like a reserve bank to regulate the flow of money in the market, but without government intervention or monitoring. Nobody wants that how many transactions I'm doing, there should be some government intervention, okay, or government monitoring. So that is the Bitcoin network. And the miner who is able to solve the puzzle become the leader. So in a system, there are open network system where some entities are there connected, and among them, one will be treated as a special node who is called leader. How they can be treated? A system will generate some complex puzzle, and that complex puzzle have to be solved by someone. They are called miners who can solve the problem earlier. They are called miners, and then they can append a new block in the particular blockchain, right? So that is the miners. So what actually the role of miners? So we assume that network is open where nobody trusts each other. A puzzle will be generated from the system. Everyone tries to solve. So it is open problem. Everyone tries to solve. One who gives the solution first become the leader. Whatever the leader say, everyone have to agree. That is the system in the Bitcoin network. That is the system in the Bitcoin network, right? Now, in this case, what is most important is called the consensus mechanism. In consensus mechanism, every new block that is added to the blockchain is the one and only one version of the truth that is agreed upon by all the nodes in the blockchain, right? So consider, before consensus mechanism, let us consider first the centralized system. Now in centralized system, suppose there are 4 entities, they are connected to each other, peer-to-peer connection. Now among them, there will be one leader. So everybody, what leader will tell, everybody have to agree that opinion, his or her opinion. That is the true in centralized system. Now there is other mechanism. What is the mechanism? That is, suppose 4 of them, they want to take some decision. What is the decision? Suppose they try to find out that what they want to do in the evening. Some of them, they're saying that, okay, we want to see some cinema. We want to go some cinema hall. Some of them, they want to find the solution that, okay, we want to go to some restaurant to take our dinner. So there are two activities involved. What are they? One is called some of the entities or some of the person, they agree to go to cinema, and some of the person, they agree to go to the restaurant. Now the question is, how decision will take place? Decision will take place on the majority voting. That means if out of 4, if 3 will be agreed to go cinema, then all will be agreed over here. And if 3 of them out of 4, they want to agree to go to restaurant, then other have to agree on their opinion. So this is called majority voting. So this majority voting will be applicable in the decision making. But in this case, the case of the blockchain, this kind of leader is not possible because they have to use this kind of consensus mechanism, okay, to find a leader. Obviously here leader is the miner. Here is the miner. And from here, the consensus mechanism actually appears. Consensus mechanism means everybody have to do something so that if one can solve the problem, then they will be the leader. Everybody have to agree on it. Okay. There is no such sharing the information, or there is no such majority of vote. If majority of vote that is agreed, then the decision will take place over here. In consensus mechanism, especially in the open network system, what's happened? If anybody solves some complex problem, then they will be treated as a leader. They will be treated as a leader. So according to the source, Wikipedia, it says that consensus decision making is a group decision making process in which group members develop and agree to support a decision in the best interest of the whole, right? And this consensus may be defined professionally as an acceptable resolution, one that can be supported even if not favorite of each individual. And consensus is defined by Merriam-Webster as first general agreement and second group solidity of belief of a sentiment. That source is given from the Wikipedia, right? So this consensus can be used by a group of people. They are scattered around the world to create more or equal and fair society. And the method, actually there's process, a method by which the consensus decision making is achieved. That is called the consensus mechanism. So one of the consensus mechanisms, there are lots of consensus mechanisms are there. One of the consensus mechanism is called proof of work, that is widely used in the blockchain. So what is proof of work? It is a decentralized consensus mechanism. Actually, I should not say decentralized because all the mechanism in the blockchain will be always decentralized. Decentralized means there will be no central activities. There will be no central control. And that requires a member of a network to expect they will give some effort to solving an arbitrarily mathematical puzzle to prevent anybody from gaming the system. That means a system, as I mentioned earlier, the system will generate some complex problem, and that problem has to be solved by somebody. Everybody will try to solve this problem. So proof of work is widely used in the cryptocurrency mining for validating transaction and mining new tokens. And here the miners solve complicated mathematical puzzle to produce the new block. So what is proof of work? Proof of work is nothing but a particular complex puzzle will be generated by the system. That system or that particular puzzle will be tried to solve by everybody. Now once who can solve the puzzle at first, they are called the miners, and miners after solving this part, they can earn the Bitcoin and produce a new block in this case. So this proof of work is one example of the decentralized consensus mechanism, right? So now coming to the next point, that is called the blockchain architecture. So what is blockchain architecture? Blockchain architecture, the basic assumption we find that there are multiple organizations or organizations spanning over the network where none of them will trust with each other. First. Number two is that an append-only shared ledger of digitally signed and encrypted transaction replicated across a network of peer nodes. That means all will get the same copied, and that will be digitally signed or verified for each of the copy, and that will be accessed by each pair of the network, right? Now, what is the structure of the block? A block is a contained data structure that contains a series of transactions, right? So it is a series of transactions. In fact, a particular block contains many transactions. In Bitcoin, a block may contain more than 500 transactions on average. Obviously, there are some limits for each of the block. The question is that how many transactions will be there? So for Bitcoin, it is maximum 500 transactions an average, and the average size of the block is around 1 megabyte. So what is the size of the block? Size of the block is 1 megabyte as upper bound proposed by the Satoshi Nakamoto. He is the first inventor of the Bitcoin. Nobody knows his real name. Okay, and this Satoshi Nakamoto, he is the miners of the first Bitcoin generator. He proposed this concept, and where according to him, the block size will be maximum 1 megabyte, and that block may contain more than 500 transactions on average, but maybe grow up to 8 MB or some higher. In fact, nowadays it is much more higher than this one, 8 MB. So larger block can help in processing large number of transactions in one go, but longer time for verification and propagation, right? So that is the structure. Now, this kind of structure of a block, there are two parts, main component. What are they? One is called block header. Block header contains the basic information for the block, and other is called the list of transactions. Other is called the list of transactions, right? Now, so this is the structure of the blockchain. See, all blocks are appended to the blockchain. All blocks are appended to the blockchain, right? You find that there are block header, and there are some 4 parts. One is previous hash, nonce, Merkle root, and block hash. So previous hash pointing to the present hash. Once again, what is hash? Hash is nothing but some hashing function that is introduced for some text to encrypt or to hash it to get the hash value. Obviously, the length of the hash value will be smaller than the particular message. And you find that there are nonce are there and Merkle roots are there. Okay. So block hash, as I mentioned, that it is some number. For each of the block, there will be some block hash number will be generated. For each of the block, a hash number will be generated. And what is the role of the previous block hash? If we show the picture, previous block hash always pointing to the current block. That means every block inherits from the previous block. We use previous blocks hash to create the new block hash, make the blockchain tamper-proof. Why it is tamper-proof? See, if I look at this figure, That means, suppose somebody try to tamper some block value, but it will be automatically propagate to all these values. So the output will be different. And if output is different, again, it will be calculated. Again, output will be different. So it is totally different from the original hash value. It will be totally different from the original hash value. Because if I use the different message, then the different hash value will be given. In fact, we can check it online that how for different message, we can get the different hash value, right? So if we look at here, suppose for example, see, this is online hashing, right? I am writing the word, say hello world, hash string. We can find this one as a hash string. Now, calculate hash string, right? This is the different software that is used. For Bitcoin, we can use SHA-256. Okay, SHA-256. Now, what is this one, this value? This value I am using as this hello world. Okay, this I am using hello world. Now, here I am using for hello world. Let me hello world. I am using the SH-256. Now I am copying this one. SHA-256. I am copying this one. I am copying this one. Right? I am copying this one. So this is called this is original message, and obviously this is SHA-256. SHA-256. This algorithm is used for Bitcoin. So this is for hello world. This message is generated. Now consider this one. Just I am changing only this part only. Just give some exclamatory sign. Any sign. Everything remains same. Just I give the exclamatory sign and again calculate the hash value. Now SH-256 copied over here. Now just check. See, it is completely different. Just a single change in the value. This is used for Bitcoin. Obviously, you find that there are different systems are there. These are the different software used, MD2, MD4, MD5. Generally, for documentation part, for digital signature, we use MD5, Message Digest 5. And for this one, that means the Bitcoin cryptocurrency, we use this SHA-256. Now, if you find this generate, is totally generate. This is the hash value. This is the hash value. So, if anybody change certain value over here, just introduction to this value, introduce this particular symbol, it is totally changing this value. It is totally changing this value, right? So that's why what is true. If it is message, suppose if I am talking about this is the message M, and that proof that if we are taking two value M, and this is M1, right? So what we are using this hash value. Using this hash value. So what I am applying? We are applying this hash value over here, H of this one, hello world. That will give us this result. Similarly, if I use H of this one, so if I assume this is M1 and this is M2, then we find that it will give you totally different result. So if from here we can prove that if M1 not equal to M2, then their hash value will be different. And that's why if we look at here, you find that if anybody try to modify some text over here, then that will be propagated to all other text. And so all computation will be totally different. All computation will be totally different, right? So that is the point in this kind of blockchain technology. So that's why this is called the tamper-proof. That's why this is called a tamper-proof solution, right? This is called a tamper-proof solution. Now, the next point is, so one is previous block. Every block inherits from the previous block. So we use previous block hash to create the new block hash and make the blockchain tamper-proof. Number two, Merkle tree root and the nonce. Now, blockchain has some unique feature. What is the unique feature? That it can store the value of the previous block as a hash value. That means the previous block hash value will be stored in the current block, which make it impossible to alter any block without changing all subsequent blocks. So suppose I want to change some value, but I have to change all the subsequent value in all other block connected with that network. So that is the part over here in the blockchain network. Now, the miners create a block and verify it and will be rewarded for using their GPU, right? Here, actually, we cannot, the computation power that will be performed by the GPU, not by the CPU, because CPU cannot solve this kind of huge amount of processing. So we need the GPU, graphical processing unit, to solve this particular problem. The block which gets more than 50% consensus will be added to the blockchain. Very common. Why 50% consensus? With more than 50% consensus, just think about it. There are 5 components or 5 nodes are connected in the network, right? Now, out of these 5, if 3 of them take some decision on one event and 2 of them take some decision on other event, obviously majority will be favor for the 3 of them. So that is greater than 50%. So with 50% consensus will be added to the blockchain, and to create a block which will be accepted by most of the network participants. And miners compete to complete the proof of work at the earliest. So what is proof of work? Proof of work means miners will try to solve the complex problem earliest, and accordingly that is called the proof of work. So the difficulty of the work that will be adjusted to take at least 10 minutes per block. That means whenever the first transaction will take place, it will take 10 minutes per block, and which become a standard time to add a block to the blockchain in case of Bitcoin network. So if we use the maximum, it will take 10 minutes to add a new block. So it's not like that every maybe a particular new block will be added to the blockchain in a case of Bitcoin network, because it will take 10 minutes to add a new block in a blockchain network. Always remind that in blockchain network, it is first of all, there are some certain size that are there in each of the block, maximum 500 transaction, average 500 transaction. But how many block will be added to the blockchain network? That is not bounded. It is unbounded. That means as much as block can be added to the network, and all copy will be possessed by all entities who are participating in this particular blockchain network, who are participating in this kind of blockchain network, right? Now, let me introduce these 2 parts. One is Merkle tree. So what is Merkle tree? Merkle tree is a data structure that is composed of hashes of different blocks of data, and which serves as a summary of all the transactions in a block. It also helps to verify the consistency and content of the data. Both Bitcoin and Ethereum, actually these are the most popular cryptocurrency, they use this Merkle tree structure. This Merkle tree sometimes is called hash tree, and it is based on this part. So suppose there are transaction, leaf node is called transaction 1, transaction 2. From transaction 1, hash code is generated. From transaction 2, hash code is generated. From transaction 3, again hash 2 is generated, and from transaction 4, hash 3 is generated. Now, a root will be set up by hash 01. So hash 01 will be combination of hash 0 and hash 1. So that will be hash 01. And similarly, another one is called the hash 23. So how it will be generated? It will be generated by hash 2 and hash 3. And Accordingly, this Merkle root now follow this hash 0, 1 and 2, 3. Hash 0, 1 and 2, 3, that will be hash 0, 1, 2, 3. So what is Merkle tree? If we look at this figure, it is different block of data which serve as a summary of all the transactions in a block. So hash 0, 1 is the summary of hash 0 and hash 1. Hash 2, 3, actually this there is some typos. Hash 2, 3 is a summary of hash 2 and hash 3. That will be not hash 0, 1, that will be hash 2, 3. Similarly, hash 0, 1, 2, 3, it will contain the summary of hash 0, 1 and hash 2, 3. Okay, that is called the Merkle tree. So this Merkle tree will also contain in the particular, if we find that there is a Merkle root and that Merkle root will contain all these transactions. So summary of Merkle tree. So we can find that Merkle tree is nothing but the tree structure which contain the summary of transaction. Obviously, here in this example, it is binary tree. It not only binary tree, it can be any tree. It can be any tree. This Merkle tree can be any tree. Okay. So here I am showing only using two transactions at a time, binary tree, but it can be any kind of tree. Now there is nonce. So what is nonce? Nonce means it is the central part of this proof of work. The short form is for number used one. So it is a random number that can only be used one times. And nonce are generated for a specific use, most often to modify the result of a function in a cryptographic communication. For that, nonce are used. So typically, nonce is a number that varies with time in order to ensure that some value cannot be reused. So it will be treated as a timestamp. It will generate some number and that number can be used once at a time. That means this is the random number that can be used one at a time and that cannot be generated many times. It is just like a timestamp of a particular specific transaction. And it can be timestamp or it has some special marker intended to prevent unauthorized reproduction of a file. Unauthorized reproduction of a file. Suppose somebody, I assume that they just hack the particular transaction, okay, by changing the hashing algorithm. Though it is very difficult. Actually, changing the hashing, it is required some million years. But I assume theoretically that somebody do that. But in that case, what's happened? If even they do that, if we look at here, suppose somebody has just, if I look at this structure, that somebody suppose change the hash function in such a way that it and make change in all subsequent block data. But problem is that here nonce will be not changed, nonce will be same. So whenever it will generate the new block, nonce will be again different. So in that way, it is if nonce actually provide the full security for any kind of block transaction, any kind of block transaction. That is the purpose of the norm. That's why norm actually it is derived from the number used once, n once, number nonce. That is called a nonce. Okay. So typically, it is a number which can vary with time in order to ensure that some values cannot be used. It can be timestamp or special marker intended to prevent unauthorized reproduction of a file. Right. Now, how transaction in a Bitcoin network take place? So give some example. The source is taken from bitcoin.it.wiki. Suppose Alice want to send Bitcoin to Bob. Very simple, how Bitcoin transaction can take place. So Bob sends his address to Alice, right? What Alice will do? Alice add Bob's address and the amount of Bitcoin to transfer in a transaction message. After receiving the address, what they will do? The Alice adds Bob address and amount of Bitcoin to transfer in a transaction message. Next, what will be the next? Next, Alice signs the transaction with her private key and announce her public key for signature verification. How they will sign? Obviously, SHA 256 message digest, sign this transaction. What is the use of this transaction? Why this is required? This is required that the amount has announced her public key for signature verification. Now, LIS broadcast the transaction on the Bitcoin network for all to see. Right? Now, what Bob will do? Bob can see, everybody can see, but they cannot decrypt the message. Only the Bob can decrypt the message. Because using the public key, everybody can see the message, but none of them can decrypt the particular message. But they can sign, they can verify that because the information is now transparent, so they can verify that the particular transaction take place from Alice to Bob. Okay, and this transaction not to send to any other person. So everybody is agreed, and only Bob will receive the message. Only Bob will receive the message. In this way, the transaction in a Bitcoin network will take place. Transaction in a Bitcoin network will take place, right? Because as soon as the allies will send the money, then immediately that can be verified by all other entities. Actually, the duplication or any kind of other part is not possible in this blockchain network. Why? Suppose Alice says, I'm assuming $500 they want to send. Now, first he sent $300 to somebody, say Bob, and again send $300 to Harry. Is it possible? In blockchain network, it is not possible, because as soon as she will send, the allies will send the $300 to Bob, at the same time, he cannot send the $300 to Harris, because he has only $200 left. And everybody can see that. So nobody can claim that you can send this $300. It's just like that. I have some money. I am issuing some same check to different person. It is not possible in this kind of Bitcoin network, because everything is clearly transparent to all of the users who are using this kind of blockchain network, right? So the next point is some typical application. As I told you that whenever we are talking about blockchain means cryptocurrency. Obviously, that is one of the major part that cryptocurrency can be implemented using the blockchain technology. But there are different areas are now generating that we can use the blockchain technology. First of all, investment management. In blockchain offers various capabilities to improve the investment management process. How? Because they are improving the collaboration of enabling everyone to access a single source of truth, easily maintain transparency, and improving the overall data security. So it has huge demand in the investment management. Trade finance. Existing trade finance has some inefficiency. That means there is some paper-based work. They have some vulnerable points. That means there is no such central trusted authority. So in this case, the trade finance, they allow the fraudulent trading, and blockchain can digitize the trade finance to enable the transparent governance and reduce the complexity and the number of intermediaries involved for faster processing to reduce the risk of fraud. For example, Trade1x and R3 launched Project Macropole, which is an end-to-end open account trade finance business network. That is another utility of the blockchain technology. Next, capital market. Blockchain changed the structure of the capital market and has an impact on each phase of the capital market trade process. Blockchain has benefits across pre-trade, trade and post-trade and security services. Digital voting. The reliability of the voting process has been a problem since the beginning of the democracy. So blockchain technology can decentralize the voting process so that election can happen securely with transparency. In a decentralized system, there is no single point of weakness, and this creates a system is more robust. So digital voting is also possible with the help of this blockchain technology. Smart appliance. Walmart that use the blockchain solution for Internet of Things. IoT stands for Internet of Things. So what is Internet of Things? Internet of Things means actually any object can communicate with other object with some RFID, radio frequency signal, or other protocol, okay, or short range signal. And that is the emerging area in the field of technology nowadays. So WorldMate is a blockchain solution for IoT where each device receives a unique identifier and users hold a password accessibility via their smartphone. And this password enables user to manage each device, knowing that all transactions and messages are encrypted and going through a secure network, and all configuration change to the device are stored in a tamper-proof blockchain solution, making all configuration change auditable. That is the special use of the blockchain in the smart appliance. Similarly, IoT monitoring, that means Internet of Things monitoring. Blockchain offers digitization of assets with IoT sensors so that organizations can label their assets and provide a transparent tracking system. So digitization enables to identify the location and condition of item. The blockchain can store, manage, protect, and transfer all this information. So that is also possible with the help of this blockchain. Smart contract. Smart contract means it is another application area of the blockchain technology where these contracts remove the intermediary by resolving problems related to the trust so that the agreement between two parties can be made more efficiently. In fact, supply chain, what actually I introduced first, that is supply chain management, is one of the use case that is used in the smart contract. Digital IDs like passport, personal IDs, marriage certificate. Now blockchain can contain the record because blockchain is used as a record keeping store. So it can could make record keeping more reliable by encrypting those personal identification IDs and allowing citizens to access this information. With blockchain technology, individuals can be in control of their digital data and the way in which it is utilized by the different parties. So that digital IDs, that will be also tremendous use. That means suppose Aadhaar number. I want to put my Aadhaar number using blockchain technology so that it will be totally in the secure form and it will be totally in the encrypted form. And anybody want to access those particular Aadhaar number, because we know that every time we need the personal ID like Aadhaar number or PAN card, if I can keep it in the digital using the blockchain technology, so anybody that is using that network can access it, okay, and nobody can tamper my Aadhaar number, nobody can fraud my Aadhaar number. So it has tremendous use. Now it is one of the exploring research area that use of the blockchain technology, how you can be more secure. Okay, so these are some few of the applications of the blockchain, although the blockchain has other applications also. So in conclusion, what we can say that first of all, even most of them, they know that cryptocurrency, Bitcoin, blockchain, they are the similar concept. No, Bitcoin, that is the cryptocurrency. What is cryptocurrency? That is digital form of currency that will be in the encrypted form. That is the Bitcoin. But blockchain is the technology through which the Bitcoin will be generated or through which the Bitcoin will be implemented. So blockchain is not a Bitcoin. Here we discuss the technology and its application, not the legal issues of cryptocurrency. That is not my part, because I am not telling anything what is the legal issue for the Bitcoin or cryptocurrency. That is not my discuss of consideration over here. I'm just using the technology as a whole. Anything in the world cannot be solved using blockchain. Now, blockchain is a very emerging area. We know that everywhere, the researcher, different companies, even IBM, they are using the blockchain. But it is not like that anything can be solved by the blockchain. Blockchain is very good. Obviously, there are different application areas there. But it is not only one solution that can change our society. That is totally wrong. Blockchain is one of the technique or one of the technology. Actually, blockchain is not a new technology. Actually, blockchain, we use the existing concept to generate the new technology. If we explore the blockchain, we find that Just consider consensus mechanism. What's happened? It is based on the majority of voting, and that's happened when we actually, suppose we have some friends, we want to take some decision, joint decision, but what we do, we can communicate with each other, and where the majority will agree, then we will be agree on that. And that is nothing but the consensus mechanism that is used in the blockchain. So it will use our existing concept. Okay, it is not the innovative concept. Once again, I'm telling you that blockchain is not an innovative concept. Okay, obviously, innovation means some cryptocurrency, that means the puzzle, complex puzzle that will be given by the system, and that have to be solved by the miner. That is the part. Otherwise, blockchain is not a new concept or new technology. Blockchain technology can be used for fraud prevention. Because we know that you can keep your Aadhaar card, we can keep our other social identification number secured way. But if we think that blockchain technology can be used for fraud prevention, there is wrong thing. Because for fraud prevention, there are any kind of security algorithms are there. Blockchain cannot be used for fraud detection. Suppose I am using my online transaction. I am using my online transaction to the public network. Now for that, there are some secure network is there. We know that there is some secure socket layer or SSL is there. Then other network is there. But for that, if I use the blockchain technology will be not used for that. Mainly blockchain technology is secure, but not in all application of the fraud detection or fraud prevention. Blockchain technology will be not used. Far better technology exists. Okay. Next point is blockchain is not a distributed database, because we find that blockchain is distributed, but it is not a database. Blockchain is used to store the data, but it is not a distributed database, because database has some physical existence. It has some storage limit. But I find that you find that blockchain, whenever all other parties, they are simply sharing the common board, and that common board or common part, and that is infinite in size. Infinite in size means infinite number of blocks can be added. Infinite number of blocks can be added to the particular block. So this is not database at all. There is no concept with the database and blockchain. Blockchain concept is distributed, but that is not database. It is totally different. And other problem here, especially in India, that a lack of awareness of the blockchain technology, because many people don't understand what is blockchain technology and how actually it will work. There are few banking system already adopted this part, but most of the system, they have not adopted till this blockchain, because they find that it is not, they cannot understand the inner technology for this kind of blockchain, right? So these are the concluding part for me, and this is the some few reference I have taken from here, and thank you.
Thank you so much, sir, for this very nice and elaborative presentation.
Thank
I
you.
must say it was a very deep presentation I saw on the blockchain technology particularly.
Thank you.
So yeah, I guess we are at the end of our today's session.
Yeah.
Before we conclude, I must tell all the participants that this complete session of 1.5 hours will be available on our Research Circle YouTube channel. So if somebody has missed or somebody was unable to attend it live, it is there on our Research Circle YouTube channel. You can just go to Research Circle YouTube channel and you can just watch this complete session. So with the permission of today's speaker, I would like to conclude the today's session here. And I would like to thank all the participants who were live from Facebook, YouTube, and from Research Circle app. And lastly, I would like to thank Dr. Siddhartha Roy, sir, for taking out the time and delivering such a nice session. We really enjoyed the session, and will surely watch if some information will be needing regarding the blockchain. We'll just go back to the Research Circle YouTube channel and we'll definitely watch again. Thank you so
Thank
much,
you,
sir.
sir. Thank you so much. Thank you.